Hi. So in the last session we saw if we increase number of features, our hypothesis function became a little more complex. And hence we were able to model our training data really well. But as a result, it may happen that as our model starts performing really well on training data, it may perform really bad on testing or new data. This may happen because the model is no more generic. It has been focused too much on a certain data, that is our training data. This is what we call overfitting. If we have a look at the definition, overfitting refers to a model that models the training data too well. It happens when a model learns the detail and noise in the training data to the extent that it negatively impacts the performance of the model on new data. Right? So I hope this is clear. तो एक और एग्जांपल ले लेते हैं. If my data looks something like this, I would want my model to learn something like this. But instead, if I do overfitting, my model will learn something like this. So these 2 points, basically these two are the outlier points, or I can say noise, have impacted my model negatively. Now this model is not a generic model. Instead, it has focused too much on the training data. So one very interesting way of getting rid of overfitting is regularization. Let's look at the definition. Regularization is a technique used for tuning the function by adding an additional penalty term in the error function. So error function is basically a cost function. So in a cost function, we will add a regularization term which will be proportional to the summation of squares of our coefficients. We will use a proportionality constant lambda. So if we have more number of features, we will have more number of coefficients, which means we will have to regularize more, right? Because the overfitting will be more when there are more number of features. Okay, so instead of lambda, some people also use C. Right? So these are the two versions of this equation. So new cost is equal to C into cost plus mi square. This cost is the cost due to error. Right? Okay. So if the C is higher, it would mean that even small training error would multiply by a big value and give higher cost, right? So we would want our cost due to training error as low as possible. Hence, we will try to do overfitting in this case, right? If C is lower, that means few extra training errors won't impact my cost that much, right? It won't impact my new cost that much, so I can go for regularization, right? Or I can say if I'm using this equation, if lambda is low and in this case if lambda is high, right? So in this manner we can choose lambda and C as per our requirements. If we want to do overfitting, we can take C more, and if we want to go for regularization, we can reduce C, right? So there are two types of regularization. One is L1 regularization, that is lasso, and other is L2, that is ridge. So the regularization that I have shown you over here is ridge regularization, or I can say L2 regularization, because it is square of coefficients. In lasso regularization, instead of this mi square, we use mi mod, right? Okay. The additional term controls the excessive fluctuating function such that the coefficients don't take extreme values. So regularization term prevents our coefficients from taking extreme values, right? So this is how regularization helps in preventing overfitting.